Hello. Hello, sorry.
Assalamu alaikum. Hello, doctor.
Yeah, sorry. I just take a nap. Then I just need to. Sorry. All right, too tired. Yeah, but
No problem.
yeah.
So we are going to discuss that
questions, please. Yeah.
Yeah, about the code to interpolate. I mean,
I
guess we agreed to discuss it.
Yeah, for the code. All right, for the code, I can explain more about the code. Yeah. The code I really appreciate. So if any particular questions, or I can start from your screen, or I can go through from the beginning, everything.
Yeah, sure. I'm opening that code.
Okay. You can share your screen. Wait 1 second. Let me allow you. Yeah, allow everyone can share. Wait 1 second. Right. Yeah, please share your screen.
1 second, just I'm trying to find this file.
Yep.
Okay, let me share this. This is your code, right?
Yeah.
Oh no. This one. So I have this array of pressures and temperatures.
Yeah. Do not use the large one. You use if your task equals 1, then you use the you are using. Wait 1 second. Let me share. How say request remote. Yeah, I request.
Yes, Yasin.
Is the session being recorded right now?
Yeah, you will see we have task equals 1. So if the task equals 1, we take the basic, right? So the basic, what your so you can use. You may have this one. So this task equals 1. If do not change, then we are use PS equals such value. I think this one maybe one you have 001. I think this should be put 1. Yeah, need to double check. Find out. Okay.
Depends on my data, I guess, right?
Yeah. So you should go to task equals 1. Just for basic one. Yeah, basic.
So this in KTM, right, or in ATM?
This in ATM. This in ATM, because you will see this in ATM, because later you will see it's divided by 1,000 inside. Where is 1,000? I will show you. All right, just wait 1 second. 1 second. 1 second. You may well. Let me find. Is somewhere here. I am not quite. Is anything? In general, is Control F. Let's see, Control F. Control F.
Yes, below here.
Yeah, then you say KATM. You type KATM to find it. Yeah, KATM. Yes. You go to it. Yeah. You'll see. Okay, here. See. So I use ATM. So here divided by 1,000. So it will convert to KATM. Yeah.
It looks like that this code does multiple jobs. I have the data. I mean, the
You already
number.
have the data. All right.
Yes. So just
Yeah.
I want to perform the last two tasks in the
I see.
Yeah.
Okay, you can put your data here. You can put your data in here, for example. Wealth task equals 1. This is at the very top, right? So you can do this. So we have the task equals what? Equals 3 or 4 or whatever. So for example, say if the task equals 3, so you will see L if, right? Task equals 3. If you okay, whatever you like, then you say you have your own data, right? So you have your own PS equals, right? You can put your data there, or whatever you have. Then you have TS. TS should be the same, plus or minus 10, plus minus 5, something like that. You can do the same like this. Right. So in this way, you can set your task equals 3 or something. Then it will do everything like this. It's the same. So you can ignore, but use your own pressures. You will see, just give you freedom. Yeah, that's something you can do. And I explain a little bit. So if you already have it, then you can ignore the first one, because the first is to just run the simulation. But if you already have everything, then you can just ignore the step 1. You just go to step 2, right? So it's just step 2. If you have that task set, then you just say get the data, then do the plots, then whatever the rest. You can do all at once. That will give you the convenience to do all at once. If you already finished that, get the data. If you finish, do not need it, then you comment out. Yeah, that's something.
Okay. Yeah. So here, I mean, still I don't see this point. I didn't see this point here. The LMP. I want to get this slope on this one. I've done everything but those two things.
Okay, 2 things. All right. For the 4 and 5, so let's go to the steps 3. Yeah, let's go to your code.
To step 3, this one?
No. In the code, in the Python code, you see. Okay.
Okay.
So the Python code, you have all the data, right? You have plot each PT. Then that's the step. You need to get ISO steels. So let's say get ISO steels. So you can you go to the previous get ISO steels. Get ISO steels.
ISO steel. I don't know.
Yeah, ISO. That's plot. This plot means we already have.
Maybe below.
Yeah, no. Up. Plot 3D up. Get. Yeah, this is something. You see. Okay, this is something you need to do. So what we have. So you should start from here. Okay, call this function. You will load this one. That means you already have something. You may need to change this. All right. You may, if you already have the data. You have your you said you already have the data. So you ask the system to load it. Yeah, you can change it to whatever you have, right? You may already have it in somewhere.
Doctor, can
Yeah.
you show us the file, how it looks like from the inside? The order of things inside, the numbers. Is it one column? Is it one row, or what? How does it look like?
No, it will be okay, it will be something like all right,
We can work with my data.
share my screen with you guys. Yeah, I can. Here I have my own data. I can share it with you. Okay.
Yes, 1 second.
Yeah.
Okay.
Yeah, I can share you with you guys what the data look like. All right. Yeah. So share my screen. Share my screen. Can you see my screen?
Yes,
Yes.
Doctor, we can.
Okay, good. All right. Then let's go to my port. I see. Go to work. CMM project 2, for example. Let's go to A. So you will see I have the data. All right, here's the data. I just show you guys how it looks like. Wait 1 second. So it will be how many lines? It will be 5 lines. Why 5 lines? Because these 5 temperatures, right? For each temperature, it will have more or less like 11 data. Here's maybe 10, right? So these are five rows and 10 columns. Each column corresponding to the pressure. Each row is one temperature. So this 2D data, right? So you guys, if you have the right one, this exactly the this exactly the CO2 ADS, this program. So we get what? Get isosceles. This isosceles, you should say whatever you like. You should do this. You should, for example, say load my data, right? So for example, you already have your own data. So my data .dat, whatever. So you just give the name for particularly your name. All right, yeah, that data file. Then just the system will pick it up from here. Right? So you can ask the system to load it from here. That's something I'd like to show you.
So rows is temperature, columns are pressure.
Yeah, I
Okay.
double check. Yeah, double check. The rows is the is 5 rows, 5 temperature, and columns, 10 columns. That's 10 pressures. So you will see what? Yeah, you will see more clearly from the code. From the code, you will see MP.0. You will see. Get the data. Then I will say the data will save to save to length of temperatures. So we have 5. Length of pressures, that's 10. Right?
That's the natural logarithm.
Pardon me?
Is it the natural logarithm? The len?
Learn is the
Yes.
length because TS is a list. PS, if you go from the very beginning, TS is a list, right? So it have some data. maybe the data have different length. So we use comments length, for example, PS means the length, ENGGH, length of the list of the variable. So
Okay, I see.
TS is a serious data, maybe 11, another one about 20, so whatever. So that's make it flexible, right? If you write 5, or then later you need to change. So you always say, how about we just take a name? Yeah, take it. How many of them? Makes sense, right? So
Yes.
use this one. Yeah. Now let me unsave, but just comment for you.
Doctor,
Yeah.
I have a question about these files above. You say when like the column are the pressures, I guess, and our temperatures, and the rows are the temperatures. Okay.
Yeah.
But I see many files, and every file has a certain temperature. What does that mean?
Wait a second, I did not get you. So you will see we originally we said this is temperatures, right? Then pressures. So I always do like this in order. Always loop for the temperatures. So this will be 5, for example, and the loop goes to all the pressures. Then we take the I as here I is the temperature and J is pressure, and take the average of the data. You will see I did not take all the data. Instead I use T2. So you will see we only do data analysis on half of the data. Why is the half of the data? We take the first half as equilibration. Right? We assume all of you have the system become equilibrated after 50%. Why we use this? Because here in my simulation, I take a large number. What's a large number? That's 10 million steps. So the first million steps, we think is just on the way to equilibration. Then we take the next 5 minutes, so 5 million steps for data analysis. All right, so we eventually, I just comment here so you can understand it better. We take only 5 million steps for data analysis, not 10 million. If you take 10 million, something you may have the errors because that data is trash. It's not become equilibrated yet.
Actually, for me, it's after like 1 million, it's enough.
Okay,
1 million.
Okay, just as I said, that will be vary from case to case. Example, you need to that's why we need to plot each of them. You need to double check if all of them have been, becomes equilibrated, or all of them at one. Otherwise, you can add another ray, like n equilibration. So you can say n equilibration. So for example, say maybe first one you take, for example, first 40% goes to equilibration, but for the second one you say I go to 3%, 30%, right? So etc. You can take a list. So later you can apply this list. Right? Yeah, in my case, I'm quite sure everything about what you know, I take everything as 50%. You may see something like this. 50%, it will be 5 million steps. It will equilibrated anyhow. So I take this. So no worry. If you run, I think all of you have the access to my workstation, right? If you do this, for the whole calculation, is only take these 50 calculations. All of them just they will finish in half an hour. So once you submit the job, you can easily get the results very soon, right? You can use your workstation to do that from the very beginning. Just give it a hint. Yeah, it's fine to redo. I really appreciate, guys. Do not use very low pressure. If you have such like a 0.001, it will give the trouble. Your curve looks bad, right? So you can do more. For example, you have more data from 1 to 10 because that one is useful data. If you go more around 100, that do not make sense too, because after 100, it cannot absorb more, right? It cannot absorb. I'd like to tell you, if it goes to 100, is eventually the system will become a liquid. It's already saturated. So it's not good to go beyond 100. Add more data from 1 to 10. That's your freedom, all right? Whatever, which data you're to go. But eventually at the last, you will see the plots. Is good looking or bad looking, just a little bit affected. Yeah.
Doctor.
Yes, please.
Can we see the plot for the figure 2?
Yeah, please. Let me stop sharing so you can.
No, I didn't do it. Not until now, but you said that you have your data. So can we say your plot for figure 2?
I'm not sure if I. Yeah, if I do have something, if I do, I'm not sure which one is directly related. But let's see. All right. Because I plot too much, I already forgot which one is this one looks like. But I'd like to share if it's. Is anything comes out? No.
No.
Yeah. Oh, okay. That's one issue. I have not opened my let's say GUI yet. Let me open my GUI. Let's see. Okay, GUI. 1 second. Open GUI. Yeah, if do not open the GUI, it cannot display the figures. 1 second. Right one. Yep. Hopefully, let's see. Can you see my screen?
Yes.
Yeah, this is the surf. You see the temperature. I take the 0 Celsius. So the middle one should be 273. Right? Then this temperature plus minus 10. Right? So something like this, and this is a log P. Right? You say take the log, and this number of carbon dioxide of salt. There's something something similar, should like this. There are many plots actually I tested.
Victor, how can this is 1 over the temperature or only the temperature?
Yeah, you have your own temperature. Yes, yes. Then you will have something similar. Yeah. Yeah.
Then we have 1 over the temperature to get the slope and to.
Yeah, yeah. You will have your own temperature and the range. Yes.
No, I mean 1 over the temperature, the reciprocal of the temperature, to get the slope and to put it in the equation and get the heat of observation.
Yeah, yeah. Wait 1 second. Yeah, you will get the heat of absorption. Yeah, you will have that.
Yeah, how to get it, Doctor? We should get the slope before. And how can we get the slope from the figure?
All right, let me show you one more figure if I clearly, let me find out. Wait seconds. Wait 1 second. Yeah. You see my screen, right?
Yes.
Yeah, you will see the system. You will have something like a isosteel, the plot isosteel. So you will see the log P, right? This is pressure, we take the log. And temperature, we have plus minus 10. So you will see, I use encode is 100. You will see sometimes the data do not look very good. Look at this one. So we take the first plus minus 6. We use this, all right? We have a lot of the 100, 100, number of carbon dioxide. So we have a lot of curves. So each curve we take this and this take the slope and then plot. That's something called isosteel, right? You should have such a plot too. And how to find the isosteel? There's the code.
Sorry, Victor, I didn't get it. It will be 0, the slope.
What means?
The slope will be equal to 0.
I'm not sure. What?
Horizontal.
Uh-huh.
It's horizontal. To me, it's horizontal. I don't know.
No. It will not be 0 because right. This is a curve and have the slope. It's a slope. I have the. It's not 0. All right. Let me show you. All right. If I log into the
Doctor, each color corresponds to certain number of n, right?
Yes, you will do that. Use the program I wrote called fsolve. You will find that. Wait a second. And see VICO2. So if fsolve, right? If you find this one, you will have this. So solve this function. This function is what? This function will do ftx. So what's f? Wait 1 second. So I have this one because f is already do the interpolation, 2D interpolation tx, py, and m, right? This is temperature, pressure, and we have the number of molecules absorbed. Right? This is the data we just showed. 5 rows, 10 columns. That's the data. Right? So we need to do the interpolation. You can think this one, we do have a fitting. We do have a fitting. This one finished the fitting, right? So use the fitting results. So we have what? We have temperature, right? We already have the temperature. The temperature is already given, right? We already say temperature. And the X. X means the number of carbon dioxide, the number of atoms absorbed. And the N. N is the target, right? The target, the number of molecules will be absorbed. The X is what? It's the pressure you need to solve, right? So this means if I know the time, the temperature, so if I know the temperature, right? The number of molecules, so you will see the number of molecules, CO2 molecules, CO2 molecules. How I know the pressure, right? So once you know the pressure, then you can do plot the pressure versus what? Versus temperature, right? Here you do not know the pressure. So you use this function, you can find it, you can solve it, right? So you can solve the number of carbon dioxide and the pressure, you find the, you know the number of carbon dioxide, the temperature, then you find the pressure. So in this one, you will solve, you have the pressure, right? But here, please keep in mind, this pressure is not a real pressure. This one is being pressure after modification. It already been take log, right? Why you're taking log? Because the pressure, you're not in linear interpolation. We already take, for example, 1 to 10, etc. This in logarithm, right? It's the logarithm. So we already take log 10 here. Just keep in mind, it not linear, not linear.
Okay, Doctor, and from where we can get the slope of the figure that you have showed us before?
Yeah, from that you will see a slope.
Yeah, from where?
Yeah, wait 1 second. Slope.
Okay.
You will see the slope, right? So I have a function. We do this one.
According to Wikipedia, Rajiv Hariom Bhatti.
Yeah. So here, say we take in range of length. For example, we take whatever. So you take the number of molecules. Say, okay, I do the slope. Slope in interception and other values. The other values you don't need to take care of, you do not need to worry too much, but I solved all of them. So you will find here, we take the slope, we multiply the R. You will see we have the constant. R equals, this is a constant. Okay, do not get too much confused. So this 8.31, this is a constant. You guys know that. I know that because the slope, you need to type R. You have R in the equation. Please go to the lecture, right? So we have the minus R here. Take the slope times this constant, then we save. Right? Then later you plot this one. Later you do the plotting. Well, I do the plotting. We have this. Yeah. We do, okay, we do not do the plotting here, but we save the R. We say, yeah, save the text. So we save this to the data file. Then at last we do the plotting. Yeah.
Doctor,
Plot. Yeah.
I am trying it right now. I got the data and it works. when I try to plot it, I add the code for plotting. It says dt is not defined. What is dt?
Could you please show your screen so you can understand better? Let me stop.
Sure.
Yeah, wait 1 second. Maybe you can just go ahead to sharing.
Yeah, I will share it. Is it sharing?
Wait 1 second. I stop share here. Okay.
Is it sharing? Right?
Yes, yes, yes. Can you increase your size? It's hard to remember.
I
to
don't
see.
know how to increase it. Is it?
Anyone can help?
ياسين
Yes.
شوف العلامة اللي يسار علامة البايثون تحت
إيه؟
في سهمين يمين ويسار.
نشوف والله.
شوف في باث مو هنا.
تحت يسار؟
لا
أوكي.
لا فوق. تحت المنيو بار هذا. لو تروح يمين شوي يمين 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 ايوه. في على اليمين اخر شيء في سهم يمين ويسار. ايوه هذه علامة اليسار.
هذا.
لا اليسار اليسار. المفروض هنا يعني.
appearance يمكن.
يس فونتس. شوف فونتس ده.
اوكي.
Yeah, I think it's better around go to higher. Okay, much better. Yeah, it's better.
That's better.
Yeah, if I can go like okay, it's fine. It's fine. I can. Yeah.
When I run it.
Yeah, everything. Okay, just okay.
Undefined dt.
Yeah, you already have the PR. You have the PE equals 0. You have the PE equals 0. Your PE is too large. Your PE is too large. That's the issue. What's your assigned temperature?
340.
340.
Yeah.
340 is about 70 Celsius. Should be okay. Should be okay. All right, you have the PE equals 0. All right. If you go to my code, if the PE is too much, then it goes to 0. Let's may I have your wait 1 second. Let me gain the control for you.
Sure.
Let me request remote control. All right. I request. Please allow me.
Yeah, I allowed you.
Yeah, okay.
Yeah.
If I remember clearly, so I say f sub. I say f sub. Right. So it's around f sub. Okay, yeah, we'll see if the PR greater than all right, PR default is 0. Then if it's less than 10, then we do the calculation, because eventually we do the 10 to the 10th. That's 10 billion. If you're beyond this curve, I mean, it's too large, beyond the 10 billion pressure. I mean, that's just unbelievable, right? Or it's too small, almost 0. Then you will always get a PE equals 0. That may be because of the interpolation. Your data is not that good, right? This also could be, let me fix it. This also could be N. Or could be N, all right, let's see. You just take N here. If you can do, rerun rerun it, can do better.
Okay.
Yeah.
It's all of them are 0.
Yeah, all 0 is not good, and that's good. So it should be. So you will see this N also affect the results, right? You need to play around. Previously, I said 0, it give something. Yeah, but what if I give 0.1, let's say, please run again to see.
Yeah, I got a better values above.
Yeah, a better values. You need to play a little bit to see. That means more of you the pressure maybe to let me see. Yeah, if the PR began larger than 10, it's set 0. If it's smaller than 10, you will see the pressure will be huge. will be around 10 billion. All right, just this.
Yeah.
Just too much. It's artificial. Yeah. There's something about. Could you please show me your plot of the first one?
Yeah.
The number of molecules absorbed versus the pressure. I see.
This is the plot for step 4. That's the same, but not logarithmic.
Yeah. Okay. You have quite a lot of data around. Okay, and this one is more good. So you have more.
Do you want to see the logarithmic?
Yeah. I see. I get your point. Yeah, your data is different from mine. Yeah, because that's temperature effect.
Yeah.
Yeah, I'm quite sure.
Should I increase pressures?
No. Wait a second. So you have this one of, so the number of molecules, the maximum is what? Is 90, right?
I haven't reached the maximum, but I think it's around 90. Yeah.
So the maximum is what? Let me see. You have 160. Then you have number of, yeah. The maximum is around 90. Yeah, it doesn't have much. It's 90. Yeah, it's 90. So you have the N card. Your N card cannot be above 90, right? You know what I mean? We have the N card. In my case, I have the real data. I mean, Monte Carlo simulation data, we do have over 100. So we just take something. So in you may just set it to be 80, right? Please,
80.
Maybe not 80. Yeah, you just 80 is also too much. Maybe 79, for example, 78. You can do that.
You mean the value in here, this one?
No. Wait 1 second. If you go up, we set the parameter called T cut. Wait 1 second. No. Okay. This is not my code. It's your code, right?
It's your code, but I added only 2 lines.
Here. Yeah, something like I said the cut. So how many add-ons of molecules in your case? In this one, I have 120 maximum, but I also cut to 100. So in your case, you may be cut to 75, right? So from 0 to 75. Even, I don't know, you may need to set the N. Okay, here is fine. Then you have, where's your N? N is here, and number of molecules. Then where's N molecules? Where's N molecules? You're here. You will see N1 and N2. Where's N1?
It's not included.
Okay. Could you please print out what's the maximum minimum? Yeah, you have this one. And let's go to now say, okay, for this one, you say return.
I write return.
Okay. Wait a second. I don't know how you're doing in this, but let's say just return. Then it will, once it's run, it just stop here.
Should I run it?
Wait 1 second. Why is okay? Okay, let's run again. Okay. Because I don't want it to have too much output, I just want to see the first few. Let me see. How to say that? How to say exit? If I have it, I just okay. Anyway, so you have the minimum is 2, maximum is 83. Actually, you have the 83. Yeah, even for, but that one is the maximum for all the data. I mean, for the 2D data. For one of you, maybe not true. So you need to, for example, if you do 75, all right. So here you need to reset N2, all right? You go to set N2 equals 75. All right, so this one, I think it will be a, wait a second, where I have made a mistake. Well, mistake, N equals 1. Yeah, should be okay. And let's see. Wait a second. In 920, 29. So 929 was 29. PY in the 29. We have mistake. Why we have a mistake here?
Wait a second.
Could you please have a look? Because okay, I think the type, all right, my type. So
Yeah.
this previously is P, but right, I typed the R here. So I think this is the right one, right? Okay.
I think so, yeah.
Yeah. Yeah, sometimes. So you will find you still do not have good one. So we have 75. What if just go to 70? Yeah. So
The minimum is okay.
minimum is okay. Minimum is okay. Let's see. Let's just do, for example, let's do 50, right? How for
Doctor, how could you judge?
Yeah, for the
Like what
50,
result of
everything,
that?
wait 1 second, wait 1 second. So you will see for the 50, everything looks okay, but your pressure is sometimes is really large. So you may change to N1 to another value to play around, right? So you will see here, if you take the 50, everything looks good, right? You will see?
Yeah. Yes.
Yeah, just a little bit. Maybe you need to change N1 to play around. Yeah.
You mean increase in one? So
Yeah, you need to increase N1. Yeah. Because
okay.
sometimes your system, you do not have the data there. That means you have a trash data near the edge, right? So maybe that's edge effect. Yes, sometimes. Yeah, so you need to use the good data, right? Only feed to the good data.
How can I judge if it's a reasonable value or not? On what basis can I say that?
Yeah, that's why you need to plot out. You will see you need to which data is very good. If you do the fitting, for example, you have the maximum for the 80, for example. But in just 80 is for a particular pressure and the temperature. For the other case, it's never have no chance to go that high, right? So you will need a function that every curve can go there. If you cannot go there, then your fitting is a little bit narrow, right?
Yeah, I got it.
Yeah.
But the plot is not showing, even though I added the code for plot
Yeah,
IPC.
it was saved. All right. Sometimes
okay, yeah.
you need to find in your folder, right?
Yeah, I think I have it.
Yeah.
Step 4. I'm not sure. I will check it later.
Yeah, please check. Yeah, because if you guys want to show, then you just use the figure show. Then you have that function. Right?
Oh, okay. Yeah. Okay.
Yeah.
Thank you, Doctor.
Yeah, you're welcome. Sorry,
Yes.
it's dropped one. Yeah, please go ahead. Have your question.
Yeah, no, Yasin asked it
Yeah.
about how to judge, because you
Yeah.
just see the numbers and you say this is a good or not.
Yeah, please show your data. Let me have a look.
Yeah, I didn't get the code, so now after this help session I will use your code.
Yeah, yeah. If you do not have that, please adopt my code and run everything in my server. You will get it in half an hour. Yeah,
I have got the data.
Wait, yeah, okay.
I have got the number of molecules, but the next step I didn't.
Okay. Okay, it's safe. It's safe. You guys just run the code and get the data and write your report. Yeah, I think that's maybe an easy way. But you will see. You also need to judge which part of the data is good for fitting. You need to think a little bit. As I said in the lecture, not all the data will be good. Some data are trash. All right, you get the wrong results. That's your judgment. Right? Yeah. Any other questions?
Doctor?
Yeah, Yasin, please.
By plotting, I can see if it's flat, then mean the data is good, right? If there is a fluctuation, then it is bad, right?
Yeah, sometimes we have fluctuation, then you take the slope, then you get the plotted. Yeah.
Can I plot it using Excel or I need to do it in Python?
I use Python. If you use, you can follow my code and do a little bit adopt, then you can do everything. Do the plotting and the fitting, everything in the Python.
Yeah, okay, I guess. Thank you.
Yeah, yeah. Yep. All right. Other questions?
Yes, Dr.
I think I need to mention that from today you can at least you can run the code on my server. Then we can come back tomorrow. I will give another session tomorrow, so I can really help you guys to have the data plotting right. You can complete your report, right? Yeah, Hassan. Yeah, please.
Yes, Doctor. I don't know. I came a little late, so actually I don't know which part in the code that you sent that we should use.
All right. So if I share my screen again, I will do very brief. All right, very brief. Let me share the screen again.
It starts at line 243.
Thank you. Yeah, you guys. Yeah, could you please share your screen to do a little bit from your own experience that may be more convincing, please.
Sure. I was going to ask you about that.
Yeah.
See. So now I just copied this. I don't know. I saw Yasin's code, and I copied these two functions: plot 3D isosters, and this one was the get isosters. So, but this is the whole code that you sent. So with which functions that we should use? Can you hear me?
Okay. I get a little bit lost, but you already have data, right? You said,
Yes, I do. This is my data.
okay. You already have the data. Okay, good. It looks good. Yeah. It looks good. And you will see your maximum will be
About 70.
yeah, about 30. But if you do the fitting, you do not use 30, all right? You only use maybe 60. It's good enough, maybe. All right. Maybe 50, all right? So you do the fitting. There's a number called N cut. Do not use too much, right? Otherwise, you will get a wrong plots, as I just.
I don't know what variable we are talking about from the code. I still.
Okay, wait a second. Yeah, it's good. So you will see the N1 and then N2. Wait 1 second. Let me request the control. So you know what. All right. So you will see the N1 and the N2, right? So N1 and N2 is the minimum and the maximum. That's for overall, right? That's for all your data. So here we'd better reset it, because reset it to a smaller one. In your case, for example, your maximum is 70. So we do not use that. You can set it to 60, all right? Or later you need to try 50, right? Something, or you can get better results. That's something. So you have these, yeah, you have your upload the data, you do the plotting.
I think I need to assign the PS array and the
PS range, yeah. And the PS here, you will see we take the logarithm here. We take the logarithm here with log 10, right? Keep that in mind. And this, as I mentioned, so it will goes to number of molecules. So it will goes up to 60, for example, 60. And yeah, I think that's something. Yeah. If you do, for example, here, if you run.
No, I still do not.
Okay, yeah, you need to change that. You need to put your data as a table. Yeah.
Yep.
Yeah, once you do this, should be fine. Yeah, once you have the data, then your use this code should be go through it, find the isosceles. Yeah.
So, doctor, is it only this this part of the code that we need? Only this one?
I think so, but for others, you may need to plot your data in 3D. Just
which one? Because you see, this is one function. This is
okay. This mainly related, right? This mainly related. Yeah. Well, you need to plot. I think the last one you need to plot isosceles. You need to plot. Yeah.
So I need only this one and the get isosceles. And this one.
I think that's two you need to work on. Yeah.
These are the only two that we need in order to interpolate.
Yes.
Oh, okay.
All right. Yeah, I hope you can work on it by tomorrow, because I will have another session 5 to 6 tomorrow. All right. So you have further questions, we can discuss there. Then you can have time to complete the report by
You see, doctor, I had my data, the number of small data ready like about a week ago.
Okay.
But we didn't know how to do this.
Okay, I see. Yeah. Please keep in mind, if your pressure is too low, then you may have your data may not in good shape. Yeah. You need to double check. Yeah. Anyway, that's your judge. Sometimes you need to add more data, right? Data points.
but it's not possible that at this time. We have only 1 day left, and the simulation is so much time.
Yeah. Yeah, you can add a little bit of, for example, you can say if the pressure 0.2 is too low for you, you may need to increase the pressure a little bit. That depends, right? That depends.
I think this is a project inside a project. Doctor.
Yeah, yeah. Because sometimes you get that data do not looks good. You also need to change the MC steps a little bit. For my case, all right, in my example, I take 10 million MC steps. So I'm sure most of the, I think all of in my case, all of them are equilibrated, right? About 5 million steps. But in your case, you need to judge it's become equilibrated after 5 million steps or not. You need to check that. Yeah. If it's not equilibrated and you take the data, then you will see, although you have do the calculation, but your data is wrong. Yeah. Just keep that in mind.
All my calculations on 10 million MC steps. And
yeah, 10 million steps is just a few minutes. Yeah, just yeah, it's
no,
still
for
before.
me, doctor, it's not a few minutes.
Okay. All right. So if you want to add more data or redo it, you can access the workstation. It will do all 50 calculations in less than half an hour. Yeah.
Last time I did 20. It took me 1 day. 20 simulation in 1 day.
I see. I see. Okay. So what's the steps you're taking? How many steps?
10 million for every simulation.
Oh, okay. 10 million will be good. Yeah. If you have 10 million, I'm sure your steps is good.
Yes, the data that I showed you, all of them are, I made my judgment based on 10 million MC steps.
Oh, okay. Great. That'd be great. Yeah. So your
the problem is the quality. Doctor. This is the only problem.
Okay. All right. Thanks for that. Yeah. Yeah. So I think almost the end of this session, we can do again. I hope you guys can do more and we can discuss again tomorrow, right? Sorry, I jumped over you.
Only one last question about the first part of code.
Yeah, please.
I don't know if we need to get the debugging or not.
First part of the code. So for the first part, the step 1 is run the simulation.
I have all the data. I have all the number of molecules that absorb.
Yeah.
I need only the second step and the third step.
Yeah, you should get the data, right? For each simulation, you will plot.
I have got it, Doctor. And I have the plot in Excel. But when I use your code, but I don't know, I'm not sure from where I can start or from where.
Yeah. Once you have the data, once you have the data, as I just showed, you mainly just need 2 functions, right? You get the ISO still, data, and the plot 3D ISO still. Then in that code, we will plot the ISO still and do the interpolation and plot out, get the heat of absorption.
You see, Doctor, the problem is that these codes are written based on your logic, right? I can write another code that can do the same function, but in different way.
Exactly. As I said,
code.
Yeah,
this
please.
is big code, and we are in the middle of a project as well as other homeworks. How can we we focus on which function we need to pick from this big code in order to do the interpolation and do the plot, which is only, this is only one step in the project. We had our data ready, our simulations were ready about a week ago, but we didn't know how to do anything regarding the interpolation.
Yeah, as you mentioned, that's critical function, maybe fsolve, right? If you know how to use fsolve, then you can do, you do not need to use my code, right? So maybe that's a critical part for fsolve. If I have something I can type, yeah. I think this most of you maybe just have the question about fsolve, right? That's a crucial one to find the isoscale. Isoscale is for isoscale. Yeah, that's if you're the two. That's the essential part for that. Others you can do your own way. All right. This is a starting point. It's an example. You do not need to follow. You can write your own code, for example. Yeah. You just take it as an example. Do not need to use my code.
So, Doctor, just for checking, the last two steps, get ISO, the 3D and the get ISO stir and the 3D plotting of ISO stir. That way I need.
You just all right. You can plot in your own way. It's not necessary to follow my plotting. All right. So essential part, you need to get the fsolve. How to use fsolve. Right? Yeah. So you have the isoscale plot. Then you get the heat of absorption. Then it should be fine.
Sure. Okay,
All right.
thank you.
Yep. Yeah. I really appreciate you guys spend the time on this. All right. Yeah, hope you guys can. Yeah, if you have further questions, please let me know in the Telegram, and we will come back again tomorrow, 5 to 6. All right.
Thank you, Doctor.
All right, you're welcome. You're welcome. All right, thank you. I will put this recording to online so others can learn from that. All right, thank you. After that.
Thank you, Doctor.
Yep. Yeah. Good night.
Thank you.
Good night.
Good night.
Yeah.